This is a video on arc sine substitution. The question states, find the integral of the square root of 9 minus x squared dx. It would be nice if we could cancel the square root and the square and the square root and the 9, but you can't do that. So what we want to do is we want to somehow merge the 9 minus x squared so we can make it a square of something. So the trick is the following. If we let x equal 3 sine of theta, then dx is the derivative of 3 sine of theta, and that's 3 cosine theta d theta. And now the square root of 9 minus x squared, if we plug in 3 sine of theta, we get the square root of 9 minus 9 sine squared of theta. And then what we can do is factor out the 9, and we get the square root of 9 times 1 minus sine squared of theta. And here's where the beauty comes. 1 minus sine squared of theta is cosine squared of theta. And the nice thing is when you have cosine squared of theta, now we don't have a plus or a minus, so we really can take the square root of each. The square root of 9 is 3. The square root of cosine squared of theta is just cosine of theta. Now we can put it all together and say that this integral of the square root of 9 minus x squared dx, well, the square root of 9 minus x squared was our 3 cosine theta, and dx was 3 cosine theta d theta. So we have the integral of 3 cosine theta times 3 cosine theta d theta. Now we can multiply that together. 3 times 3 is 9, and cosine theta times cosine theta is cosine squared theta. Pull the 9 out, and you get 9 times the integral of the cosine squared of theta d theta. Now I could use the half angle formula. The cosine squared of theta is 1/2, so we get 9 halves, times the 1 plus cosine of 2 theta, d theta. Now this is an easy integral. The integral of 1 is just theta. For the integral of cosine of 2 theta, we use u substitution. If you let u equal 2 theta, then du equals 2 d theta, or d theta is 1/2 du. So we end up with 1/2 times the cosine of u du, and that's just 1/2 times the sine of u, or 1/2 times the sine of 2 theta, and then plus c. So we're not quite there yet because we have a question about x's, and now we have thetas. So we need to turn these thetas into x's. So the first thing we want to do, because we have sine of 2 theta, and there's nothing over here that has a sine of 2 theta, but there's this beautiful formula that the sine of 2 theta is 2 times the sine of theta times the cosine theta, and the 2 and the 1/2 cancel. So we end up with 9 halves times theta times sine of theta cosine theta plus c. Now we can substitute back in. So we look at the theta, but we know that x equals 3 sine theta. So divide by 3 and take an inverse sine. So we could say theta is the inverse sine of x over 3. Then we have a sine of theta. Well, sine of theta is x over 3. So here's the x over 3. And then we have times cosine of theta. Well, 3 cosine theta is the square root of 9 minus x squared. So I just divide by 3, and we get 1/3 times the square root of 9 minus x squared plus c. Now I can simplify that up a bit. I can multiply the 9 halves through. So I get 9 halves times the sine inverse of x over 3. And then the 9 and the 3 and the 3 in the denominator cancel. We have an x over 2 times the square root of 9 minus x squared plus c. And I'm done with the problem.